It has the part number A09103. It has 9 leads. A 103 probably means 10K. Let's take a look between 2 leads. $20K. $20K. Well, 19.89. Go down here though. $10K. 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 So what we have is 8 resistors. Each resistor has 2 leads. And so on, where this is 10K, 10K, 10K. We need to find out which is the common end. It's one end or the other. Well, if I put the lead here, I read 10K. If I put the lead here and here, what I'm doing is reading from here to here, or 20K. So this end is the common end. I could have guessed that because the marking is, anyway, when you're reading the marked end, the markings, it's the common is to the left. That seems to be the way things are done. If you look at the board, there's a square solder pad and all the rest are round. And the marking is on this side. So if you put the markings this way, and stick this in, I think we'll be fine. I'm going to bend the leads a little bit on it too. Just the end leads, so it doesn't fall out. Now I'll proceed to solder it. Now when I solder a part like that, I usually do each end. Then I'm going to put my finger underneath the part. First on one end, and I'll melt the solder and make sure it's tight against the board. I'll move my finger to the other end while I'm pressing down. I'll melt the solder. That guarantees that that device is tight against the board. Then I can solder all the rest. There's a 4-pin socket right here, marked for a LM393, and it's got a square outline. well, rectangular, with a little notch indicated at one end. The socket itself has a notch at one end. See that? So we just line that notch up with the notch on the board. There we go. It's laying sort of flush on the board there with the notch at this end. Turn it over and I'll bend the opposite pins. The diagonally opposite pins get bent over. And like I did with the resistor, single inline resistor package, I'm just going to solder the corners that are bent over. One there. And one here. So just two corners soldered, and use a rag to prevent. I don't push on it. I use a rag to prevent burning my finger. I don't push on it until the solder's melted. I'll move my finger to the other corner. I'm not pushing. I am pushing. That way that socket is seated firmly against the circuit board. Then I'll proceed to solder it. I have a little crystal here. It won't stick up very high. It's marked 12 megahertz. Here it is. 12 megahertz crystal. Treat it like everything else. I found these three little ceramic capacitors. They are marked 102, 102, and 22 maybe. Here are a pair marked 102. See that? There's no box around them. Capacitor symbol is there. And 102, 102, that's the value. These are non-polarized, but I put the writing on these so I can read it viewed from the right. And they should just pop in there. Now, do we have another capacitor symbol? Yes, here it is. And it's marked 22P. And the capacitor is marked 22. We might as well go ahead and stick the big socket in. Again, it's a square outline with a notch. And there's a notch in the socket at one end. Make sure all the pins are straight. It should just fall in like that. Again, bend two diagonally opposite pins. Out of the pins you've bent. Again with the rag, don't push until the solder melts. And then proceed to solder. I think there's about 40 of these terminals. Some people prefer to hold these things in a clamping system, elevated vise, some sort of a board holder. I like them laying on the bench so I can plant my wrists. That allows me to be a lot more stable and accurate than if I was holding it up here somewhere, which is why I like these QRP Me blocks. One thing that will lay flat later. We have a socket. It has an open space at one side, not at the other. I'm thinking that goes here with the open space where this offset is in. Like this. And like I warned, we'll have to move the QRP Me, get it out of the way. Stick him in. Come on. There it goes. For some reason it seems a little tight. You heard it snap. So that's good. It's self-holding. I found another 105 and another 22 ceramic capacitor, and the 105 goes in here. And the other 22 goes up here. Just seems to be very commonplace. We have 3 of these little electrolytics. I don't know if they're identical. They're all 10 to 25. Okay. Now, electrolytic capacitors are polarized. They have a long lead and a short lead. And they have a white stripe. White stripe, which is marked negative, and a long lead that normally means positive. So there's a negative and a positive marking on them. The little round circle indicates a capacitor, 10 microfarad in this case. And you see how the half of the circle is slashed lines? That's the negative side. And so this hole with the cross slashes is where the line on the capacitor goes. Here. And here. Now you must put these in the correct polarity. It's very important. And here's a 4th 10 at 25. And he's the one that goes underneath the processor. So he's polarized. And it can't be allowed to stick up. So what you need to do is pull it up a little bit and bend it over, so it lays down flat. We have 3 bigger electrolytics, here, here, and here. And just like the little ones there, a stripe on the negative side, and a long lead, not a focus, on the positive side. They'll go in here. They actually have a plus. The silk screening is, the compound is big enough that they can work a polarity, as well as the white. And we have an LED. It's actually called D13. An LED is a diode, and it's got a positive mark on it, as well as a negative. Well, the diode has a long lead. The LED has a long lead, and that will go in the positive. It'll lay down completely flat against the board like that.